From a young age, we are taught in school that like charges, whether both positive or both negative, will repel each other, while opposite charges attract. It turns out that under certain conditions, like charges can actually attract each other instead. In work recently published in Nature Nanotechnology, researchers at the University of Oxford have demonstrated the attraction of like-charged particles in solutions. The journey began for the lead scientist Madhavi Krishnan back in the mid-2000s, when she came across the like-charge attraction problem while studying how DNA molecules squeezed into slit-like boxes. It was expected that the DNA would flatten into a pancake-like geometry, but instead it aligned alongside the edge of the box. Without any external forces being applied, the only explanation was that the DNA was attracted to the box, despite them both being negatively charged. Thus, an interest in how attraction and repulsion may not be as they seem was born. The like-charge problem is not new knowledge though. Different scientists over the years have tried to explain how like charges can attract, with some of the earliest works coming from Irving Langmuir back in the 1930s. One of the areas where like charge attraction is seen the most is within fluids and the interaction of solid matter with fluids. I encountered the problem early in my trajectory as a scientist, Krishnan tells Physics World. Considering the observations entailed such a fundamental departure from the current understanding of a basic and central phenomenon in the fluid phase, turning away from the problem was never going to be an option. Attraction of like charges in fluids has been seen many times using multivalent ions, but these are known ionic species that are exempt from d'Alveo, Durgigan, Landau, Verwey, Overbeek theory. The expectation that like-charged molecules will repel at long ranges when van der Waals forces are too weak to influence the interactions between molecules. However, a number of molecules that are expected to follow the rules of d'Alveo theory, such as nucleic acids, liposomes, polymers and colloidal particles in aqueous media, have been shown to possess some level of attraction when like charges are present.